to finish this key. It needs one slot about here and one hole for M6 bolt around about here. The M6 bolt is for that hole. There up goes like that into there, and then this key is then screwed with that one into place, and it should be below the surface. Below the surface. And well, this is tool steel, so it's a little bit hard. But so I will now measure the distance from this end to the hole. I will now measure the distance from this hole to the end to there. It's not critical once again. It doesn't matter if this is, for example, 0.5 millimeters on the side. But it should be exactly on the middle, because this will, when you screw in the bolt, it will jam if it is not in the correct place. So, well, I'll do that, and then we go to the milling machine, make the hole, make the sinking for this one. And then another thing is that we need to make a piece, something like a slot here, about there, I believe. And this one is for nut. It's a quadratic piece of steel which you put there, and it has an M10 fine thread inside. And when you screw it, it will move the tailstock along with that one. And it doesn't need to be attached to anywhere, just the thread, and when it's sitting on the slot, which should be quite exact, the match should be quite good. So then, well, let's see. Okay, I'll do some measurements and then we go on to the milling machine. This here is now a setup for drilling a 6mm hole. It was 32 millimeters from the end. 32? Really? No, 38. And then the width of this thing is exactly 12 millimeters, so it will be 6 millimeters from the side. I have locked the table and everything. And it looks like I need to change the battery. So now we drill the hole, and again this is tool steel, and the cuttings are really sharp and hard. So the table was locked, and well, just drill through. This is the automatic feed, and now this time we need a little bit speed here. We need to change to high gear. Like that. Okay, next will be putting the recess for the Allen cap. Here we have now an end mill that is producing 11mm hole. And since this is 12mm wide, it leaves 0.5 millimeter on each side. Okay, it's enough actually. And then we need to put it 6 millimeters down, so it means 4 total full revolutions on the wheel here. So, let's go. I changed the speed a little bit lower, as you can see. This must be well lubricated. This is just a high speed thing, and let's see now where we go. I will now do rest of this whole of the camera. So, there we are. There is our hole, and this one goes there. Well, this is the only suitable end mill I had for these. The nominal diameter for this should be 10 millimeters. But looks like my end mills are regrinds. So therefore they are small, too small for this one. So this is 11 millimeters, it's really loose in a way, but well, it does the job. And there is really 0.5 millimeter each side, so success. And didn't break any tools, and the setup was, I would say, correct this time. Hopefully I don't become cocky with this one. One can really easily destroy things with this. So there is my tool for extracting this away. Yeah, this one was holding it. And yeah, I need to deburr it, and after that I can fit it in place. Let's see how it does. Well, change of plans. The original hole, which you can see there. If you look carefully, you can see it's nowhere in the middle of it's nowhere in the middle of the groove. It's about 1 millimeter in one side. So, lucky me, there was this pinhole for a pin. Well, I just turned this thing around, and well, now we have a correct hole in a correct place. I threaded one of those, and then I needed to shorten this a little bit, quite a bit exactly, and it goes there, and everything goes in place very smoothly. Okay. Now this makes it so that when we put this comes here like that. So we need to, because now my original plan was to have, where is this now? Yeah, my original plan was to have the nut on the other. Well, I need to mill a slot in here, and now the next thing is to determine where in the heck should this slot go. So if this goes about here, so you cannot put it into the middle, because there is this bolt that is going through to the lathe bed and tightening all this up. So we need to put it somewhere around here. Near that one, but far enough so we can have a little bit of moving room. And this is the amount of the slots here is the amount of moving room we should have. So I can tell that the slot should be about there. So here we go. Now this is producing something like 8 millimeters. I need to put a slot here, 6.5 millimeters, 6 millimeters deep, and well, the white becomes what it becomes. I'll then adjust the nut accordingly. Well, yeah. So I will take 1 mm passes. I have quite a few here. This is a carbide instrument. So there you are. That's 6 mm, no, well, 6 mm deep slot. Is it? Let's check. It should be. Well, it's quite beautiful actually. Oh, yeah. Well, we have some burr there. Oh, yeah. Uh-huh. Well, it's 500ths of a millimeter under. Okay, fully acceptable. Well, I have started to make the nut. This is just cleaning the surface, and now I'm using auto feed and I'm taking 0.5 millimeter away from the surface. Let's see how this goes. So you can see the back side is rubbing just a little. Okay. Now I will just deburr it, turn it around, do the same thing there. This dimension is not critical at the moment. And then I will do the big surfaces, and then I probably want to use, well, I use the same mill, just run it twice. And then let's see what happens after that. Okay, now only the ends are not in a, well, they are rough. But otherwise the piece is now, well, it's not nice exactly, but it is quadratic and it's, yeah, okay. What we need to do now is to get it the correct thickness. Let's measure it again. Looks good. Okay. 7.95. Well, okay. If it is too big, so which I doubt, if it is too big, so then I just file it down or sand it down. It's really easy to get rid of that amount of, and I probably also need to sand it a little bit, but I assume this is the correct size. But now, what we need to do here is to bore a hole in the middle, and this hole should be perpendicular to this surface. So I don't release it. So that's the reason why I had this extra piece of thing here under. Hopefully I can get rid of that easily. Let's try to get it away from there, like that. Okay. Yeah. And now we need to bore a hole in the middle. and it needs to be, according to this book, drilling, common thread forms, calculation, tapping drill size, metric, special pitches, M10.1. Here we have it. M10.1. Okay. And well, my major, how come 10? But the minor is 8.773. Well, I don't have a drill like that, but if I make the hole 8.5, then I have something like 3/10 of a millimeter to, yeah, it should, I think it should be okay. So it will be a little bit tight when I tap it, but well, so 8.5 millimeter drill. Well, I needed to get a little bit creative here. This is the tap, and it's a little bit loose there. Actually, there is a double pin which is in the collet, and then this is tightened to the double pin, and then this fits loose there, but let's see now. This will be an exercise, really. Well, what can happen here is that I destroy my tap and the workpiece, of course. Well, it's true. There you go. Thread. Well, how did it fit there? Well, there is the groove there, and here is the piece, and the other side is tiny bit loose, but the other side is not. This means that my milling was not, it's not parallel. But if you put this side in, it's so tight that it doesn't move at all. But it goes there, nevertheless. And what I also noticed now is that I don't need to take anything away from the side. It's, oh man, this is really tight. Please come away from there. How on earth? Okay, so I probably need to shim it to get it, because I don't want to have this kind of wiggle there. I want it to rest on this surface and not turn anything. But I could actually put adjusting screws into it. That's an idea. But not a bad idea at all. Okay, well, yeah. Well, let's see how it is. So now what I need to do is to beautify it, because these ends here are rough. These are hacksaw quality. Well, we have now created this piece of, machinery. It's a nut, and now we need to make the screw. Well, I don't have an M10 fine thread die, so it will be single point threading in lathe. And now, since our tailstock is in that condition, I need to put it one more time together temporarily, and after that we should be good to go. One thing I could probably do for this one is an adjusting screw here, so that you could take away this little from there. Okay, but let's see how we do with that. So I got the tailstock. Now it's repeating in 300ths of a millimeter. There is something going on with the lathe bed. Whenever I tighten this nut, it twists. I don't know why, but it does. And so I need to tighten this nut to a certain tightness. So then it repeats. And I will show now what I did under here. This is now what I have done with this thing. There is an M10 thread here, and it rotates with this one. I don't want to loosen this one because I already adjusted this, and it's really a thing. There is the nut, and I filled the gaps with epoxy. Epoxy is not to keep it in place, just fill the gaps. And it works really nice. And it repeats. So this is now end of the tailstock. I don't want to do anything for that one. Next thing, when I want to make this lathe better, well, one thing to make this lathe better would be to change the whole lathe. That would be one. But since that would be arguable with my wife, for example, the economics would not be so good. So therefore, the next thing to make this better is to create some auto feed on this one. The auto feed is using the same gears as the threading, and that's bad actually. The slowest speed is way too fast for me. And then it would be really nice to adjust the feed linearly, stepless adjustment. That would be nice. Maybe in some of the next episodes I will do that. Till then, see you!